In this video, I'll walk through two different examples that use the substitution method to solve an equation. What we're going to do is think of these two equations as quadratic-like. So because they're quadratic-like, we could either use the factoring, square root property, quadratic formula, or completing the square method to solve them. But to start with, you have to get comfortable with recognizing that the equations are quadratic-like. So let's look at the two examples. Now these two examples might look very different from each other, but notice that in some ways they're very similar. They both have three terms, and you can almost see them as a quadratic equation. So let's look at how to use substitution for these. To start with, though, I'm going to rewrite this first one so that it is equal to 0, and then it might become even more clear how it's quadratic-like. So I'll subtract 85x squared from both sides and add 49 to both sides. So I have 0 on one side of the equation, and then I have 36x to the fourth minus 85x squared plus 49 on the other side of the equation. Now the second one is already set to 0, so we're ready to go. The first step is to recognize the substitution. Now our book, I'll be honest with you, makes it pretty easy. The examples they throw at us makes it pretty easy in that you can usually use a substitution for this middle term. So this negative 85x squared, we could use that x squared. And I'll tell you now that that's going to work for our second example also. And because we're just being introduced to this new method of solving different types of equations, that's usually going to be the case. But here's how you test that that's going to work. If we do let u, and the reason we're using u is just to be standard across various pre-calculus students are going to use the same substitution, and you'll see that u substitution used in calculus as well. So you might get in the practice of using u, though you could use any variable you want. You could think of it as like a stand-in variable. We're going to pull out the x squared and we're going to stand in the u in its place. Now here's how you can verify that that substitution of u equals x squared, that this x squared is the one that works. If I were to let u equal x squared, then I can see what u squared would be because I take the x squared and square it, and x squared squared is x to the fourth, and notice that that's what our lead term has, as an x to the fourth. So if I make this substitution, then what I'm going to have is that this 36x to the fourth becomes 36u squared because x to the fourth, we're substituting in the u squared. Minus 85x squared becomes minus 85u because we're substituting a u for the x squared. Plus 49 equals 0. Once I have that, I can then notice that if I factor 36u squared minus 85u plus 49, I'd get 36u minus 49 times u minus 1. I could check that factoring by using FOIL. 36u times u is 36u squared. 36u times negative 1 is negative 36u. Negative 49 times u is negative 49u. When I combine those, I get the negative 85u. And the negative 49 times negative 1 is positive 49. So I can check that foiling was correct. And now I'll solve the quadratic equation by setting each of those two factors to 0. So I let 36u minus 49 equal 0. Adding the 49 to both sides, I'd get 36u equals 49. So u is 49 over 36, and u minus 1 is equal to 0, gives me u equals 1. Now, I have solved for u, but notice that this equation is asking me to solve for x. So the final step when I'm using substitution to solve an equation is I have to go back to solve for the original variable, the x squared, or x actually, but I'm going to start by solving for x squared. Here's how you do that. You use a substitution. Now we've got that u was equal to x squared. And if u is equal to x squared, I can back substitution this 49 over 36 in for u, because I solved that u was 49 over 36. And if that is equal to x squared, then I can solve for x. And now I've got to solve another quadratic equation here. And the easiest way to solve this one is really going to be using the square root property. So I take the square root of the x squared to get x, and then I'll square root the 49 over 36. But don't forget that when we use the square root property, we get two results, the positive and the negative value. So what I've done here now is I've solved for x equals plus or minus the square root of 49 over the square root of 36, which is 7 over 6. So far, I have two answers. X is 7 over 6. X is the opposite of 7 over 6. But I'm not done yet because I need to do the same now for this second result, the u equals 1. So going back again to the substitution, if u is equal to x squared and u is 1, then when I have 1 equals x squared, I could take the square root of x squared to get x. Square root of 1, but don't forget to use the plus or minus, the positive or negative 1. So I get that x is 1 or negative 1. So there's the full result for this example. Let's try the second one, and it's using the same method. We're using substitution again. So let's see what would happen with this. We can start by using our substitution. We've got that u is the square root of x, and when u is the square root of x, then u squared is the square root of x squared, or x. So I can put that substitution in. So we see that when we make that substitution, the x becomes the u squared. The square root of x becomes u, so we have u squared minus 18u plus 77 equals 0. And now I'll solve this quadratic equation for u. And don't forget, when I finish solving for u, I'll need to go back and do the back substitution to solve for x. But starting with the solving for u, I can see that this will factor because I know that 7 times 11 is 77. 7 times 11 is 77, and that if I made those both negative, the negative 7 plus negative 11 is equal to negative 18. So it looks like this will solve factoring u minus 7 times u minus 11 is equal to 0. So each of those factors to 0. So u minus 7 is 0, gives us u equals 7. U minus 11 equals 0, gives us u equals 11. But I'm not done yet. And then using the back substitution, if u is the square root of x and u is 7, then 7 is the square root of x. I can solve for x by squaring both sides. And I'd get that x is equal to 7 squared, or 49. And then if u is the square root of x, and I've solved for u is 11, then if I square both sides, I'd get that x is equal to 121. So it looks like our two solutions are x equals 49 and x equals 121. If you do need further help with this type of example, I hope you'll let me know. And good luck finishing up that other practice that you're working on. Could I encourage you, even after you go back to fill in answers for these results, you might find it beneficial to look at the bottom of your page when you're logged into this example and ask for a similar question, and make sure you could walk through a similar question on your own.